In StatCrunch, remember, we already have our data loaded and we want to create a picture. So we're going to click Graph and we want to do a box plot. Doesn't call it a box and whisker plot, they just say box plot. And again, we're talking about the serial data, but this time we're talking about potassium. So I'm going to click potassium. And I don't necessarily have any specifics I want to give here, so I just want to say go ahead and compute. And here's my picture. Actually, I'm going to go into my options, and I want to edit it so that I want to draw my boxes horizontally. I prefer that. So here's my box, and so you can see the number line at the bottom. Notice that we have these dots here. What do those dots mean? I'm going to take this screenshot of this and bring it back over to our notes so I can write on it and describe more in detail. Okay, here I've got my picture. Hopefully you can see these dots right here. What are these? We didn't say anything about not connecting. We talked about going from our Q3 up to our maximum, but this goes obviously beyond that. What these are their outliers. So we represent outliers by using, depending on the graphing software that you're using, you can use an asterisk or a dot. This is the maximum here, and this is the minimum. Notice that this is the interquartile range, and 1.5 those is about, well, here, that's where that line is. And then anything above that is considered an outlier. Now, unless you have the data set, you're not going to know exactly how many outliers there are. You can just say there's at least one. If the maximum is higher than Q3 plus IQR, or 1.5 the IQR, or if the minimum is lower than 1.5 of the IQR minus or subtracted from Q1. Okay. Does this data set have any outliers? Yes, it does. And it has at least 4, as seen by the dots. What shape does the distribution have? Well, we'd consider this whole thing to be a tail, so it is skewed towards the tail, which is to the right. Considering this, one thing I want to say is if the maximum is greater than the Q3 plus the 1.5 IQR, or if the minimum is less than the Q1 minus 1.5 the IQR, there is at least one outlier. And we would have to look at the data to be able to determine exactly what the numbers are. Okay, create box plots for the sugars and carbo columns. I'm going to bring us back to StatCrunch now. We still want a graph. Now we're just going to collect 2 things. So we go to Graph, Box Plot, and now we want to select sugars and carbohydrates. Remember, you want to click the control button on a PC. And I like to draw mine horizontally. And now we go ahead and click Compute. How do the spread of the data sets compare? What we're looking for is how spread out are the data. Are they both very spread out? Is one more spread out than the other? Well, there's 2 things you want to consider when we're talking about spread so far of what we know. We want to talk about the range, and we want to talk about the interquartile range. How does the middle 50% compare? Well, on carbohydrates, the IQR is less than sugars. And you can use the number line to approximate. Maybe we're looking at 12 and 17, so maybe this is an IQR 5. We could run the numbers in StatCrunch. We want to put this down here. Maybe we're looking at 10 and 3 or 4. So maybe we have an IQR of 6 here or 7. And then the overall range, do that in a different color here, goes from 0 up to about 15, whereas this one goes from 5 to 25 maybe. So the IQ or the range of carbohydrates is 20, where the range of sugars is 15. So the range is greater in carbohydrates than in sugars. We have different measurements that we could use. We could be using the range, or we could be using the interquartile range to compare the two. And depending on which one you're using, as you can see, they're different. Typically not always the case. And then you have to consider your data as to which measure of center you really want to use. We'll learn later on that we kind of want to move towards an IQR rather than just the range, because the range doesn't really give us a great picture of everything. Now, how will typical data values for each set compare? Remember that a typical value is the center. So typical is our measure of center. This measure of center here for sugars is much less than the measure of center for carbohydrates. So the center for sugars is less than the center for carbohydrates. All right. Thank you for watching.